Welcome to the global launch of Kehua Central Inverter. I'm Tian Tian from Kehua Marketing Team. As a company with 32 years industry experience, we sincerely believe that it is innovation that truly brings benefits to the end users of solar power. What we are doing today is to present to you the innovative solution that breaks the limitation of traditional central inverter and further decrease LCOE. And we're honored to have Lin here. Lin is our technical director, and he will lead us through the conference. Welcome, Lin.
Thank you, Tian Tian. Okay, good afternoon, ladies and gentlemen. Welcome to Kehua Product Launch Conference. This is Lian Pen from Kehua Tech. Today, we are going to witness the world's first 4.167 megawatt central inverter going to the market and how it decreases LCOE of your power plant. Why this number is so important? Because 4.167 is the key to break the limit to decrease LCOE. Before we start the how part, let's talk about what are the limits. Here are my points. First is the block cost. As we know, the power capacity of PV panel grows over 30% every year. So the block design will be very different. Can inverter match the future block design trend? And what can we do for the block design optimization and connection improvement? Higher power generation is another way to lower the LCOE, like efficiency, DC-AC ratio, and clipping loss. These things are all cause the limitation of generating more power. We need to focus. And the safety and reliability also have a strong relation with LCOE. And furthermore, the personal security. So as an inverter, although it has multiple functions to keep safe and reliable, it is not enough. What we can do to bring it to a higher level? A breakthrough is needed for safe operation, reliable analysis, and technical innovation. So now let's discuss how to break the limitation. First is how to lower the block cost. Currently, in order to lower the cost of the block, the inverter should match the future design and support the BOS optimization. What is the future design? As we know, the power of PV panel will increase 1.33 times in the next year. To match the density growing of PV panel, the power of inverter should increase as well. Thus, 3.125 megawatt inverter multiplied by 1.33 times capacity growing is 4.167 megawatt. So after this growing, is the block cost different? We could find this answer in this page. The total cost of block design consists of many parts, and there is always an optimal point. For example, we can see that when the block size gets bigger, the cabling cost is increased, while the foundation and the construction is decreasing. Here, an optimal point appears. Based on the same principle, the whole system costs also have an optimal point. Here we compare the cost of 3 blocks based on different inverter capacity in the market. And we found that the cost is lowest when we choose the block based on 4.167 MW inverter. Besides, if the inverter can integrate with the auxiliary system and local SCADA inside, we will save block cost by 1% by saving labor and the foundation cost. We can see here, we have reserved place in here to integrate the auxiliary system, control cabinet, multi-system, and so on. By building the turnkey solution, another 1% is saved by reducing the cabling and the construction cost. Moreover, flexible output options will solve most of the challenges in the real-world application. Bus bar on the top, on the bottom, and on the side, and also cable on the bottom on the side. You see, it's very flexible, and that will truly bring benefits to the EPC and the end customers. Next, we are going to discuss higher power generation. Nowadays, most of the central inverter only have 1 MPPT. The maximum DC-AC ratio is only 1.8, and probably no ESS connection. These things limit the power generation to a large extent. So what can we do about it? As I mentioned before, most of the central inverter only have single MPPT. Even the LAN is flat, we still need to handle the complex weather. We can see the graph on the right side. During cloudy days, we can see this point here and here. K-HUD 3 independent MPPT inverter have more power generation comparing to the single MPPT. And the power generation increased 1.5% in total everywhere, every year. I think that's more than extra $2 million in 100 power plant, 100 megawatt power plant in 25 years. And based on 32 years experience, we know that the efficiency of inverter is relating to software, hardware, and the structure. That is why we need to enhance the efficiency of 3 parts to achieve a total 0.6% increase of power generation every year. I think it's another $0.8 million in 100 megawatt power plant in 25 years. And the different regions have different DC-AC ratio requirements. And then as you see on the left side, what maybe 1.8 is not enough and will cause generation loss in some area. What's more, with the percentage of renewable energy growing higher and higher every year, we are thinking about the PV plus ESS solution. The inverter need to reserve DC capacity to connect to ESS system. Based on our research, 2.5 DC-AC ratio will meet the requirement of a future PV plant and the future PV plus ESS solution. And then we go to safety and reliable. I think safety and reliable is a permanent topic in every industry. And what can we do for the PV power plant? Let's discuss. The current situation of central inverter is, for example, no power redundance, no truly auto type, no night protection, cannot support grid analysis. So how to solve them? For power plant, as we know, uptime is money. And uptime is related to reliable operation. Modular design can reduce the fault scope. We can see the pictures on the left. Even one module is failure, the other two modules still running. We will still have more than 60% power, and it is also easy for OEM and faster recovering. You see, every key components is easier for replace. Therefore, the uptime of PV power plant will be improved. And most of central inverters still use cotton field for the IP level and one air duct for the airflow. For a truly outdoor inverter, do you think these are enough? The patent heat exchanger solution developed by Kehua replaced the cotton field, and the two independent air ducts can avoid heat mixture. You can see this picture on the right. We do not need to worry about the hot air coming from the inductor, which directly go to the IGBT and influence the life cycle and reliability of IGBT. We are very confident that this patent heat exchanger and the two independent air ducts can ensure truly outdoor application. Besides, 24 hours running is more and more popular in a PV power inverter. And every manufacturer of a PV inverter have done so much protection function in the daily generation time. But how about at night? Can inverter do protection when the night SVG functions or NT-PID function is running? When the O&M person is working at night, can we feel safe? So for 24 hours safety and reliability, Kehua develops a patent AC fault detection function which can ensure personal safety. Grid analysis can help the PV power plant optimize the operation. Usually, the SCADA of power plant cannot observe the instantaneous status. For example, when LVRT or HVRT happens. When the harmonic grows up, the OEM team have no records. So how can a power plant operate better without the instantaneous electrical records? Recording function is very important to support a reliable and safe operation, I believe. Okay, I think till now we have analyzed several key problems. Now I'm presenting you the solution of the power mentioned above. That is Kehua 4.167 megawatt central inverter. Modular design, high efficiency, high overload capacity, and high IP65 level protection, which let the 4.167 megawatt inverter have a beautiful face and a strong body. To summarize, safe block cost over 4%, higher power generation over 2.1%, 24 hours saved, and the patent cooling system, which enables Kehua 4.167 megawatt inverter to break the limitation of decreased LCOE. After calculation, we are very excited to find the line. The result is 4% LCOE cost down. We are very confident that the 4.167 megawatt inverter can help IPP and EPC reduce the cost while ensure safety and reliability. At the end, I would like to show some applications. A 16.5 megawatt project is ongoing a couple months ago in China. K-HUD provides the 4.167 megawatt turnkey solutions. And these solutions can help our customers save the labor cost and the foundation cost. A 25 megawatt project is under delivery stage, which will install in Europe. Ke-HUD 4.167 megawatt central inverter now have passed all the certifications of IEC standard and the region grade code. We are 100% sure that the 4.167 megawatt inverter is ready for any projects all over the world. That's all. Thank you for your listening. Contact with us if you are interested in this world's first 4.167 megawatt central inverter. Looking forward to our cooperation. Thank you.
Thank you, Lin. Thank you for presenting the great solutions and products to us. For more information, you can visit our official website, www.kehua.com, or follow Ke-HUD Tech on LinkedIn, Facebook, and YouTube. Stay tuned for the latest news and see you next time.